This video is on the solution and specific it is on the topic colligative properties of solutions. So what are colligative properties? Colligative properties are those properties, remember, which depend upon only the number of molecules. Colligative properties are the properties which depend upon the number of molecules and not on the nature of the molecules. So colligative properties are the properties which depend on the number of molecules and not on the nature of the molecules. The colligative properties are four in number. The first property is known as the relative lowering of vapor pressure. The second property, colligative property, is elevation in boiling point. The third colligative property is depression of freezing point. And the last colligative property is osmotic pressure. So we are going to discuss them one by one. The first colligative property is relative lowering of vapor pressure. We have already seen this colligative property in the previous video. So whenever we take a pure solvent, and suppose P naught is the vapor pressure of the pure solvent. If P is the vapor pressure of solution, P indicates the vapor pressure of the solvent in the solution. So what is it? What is observed? Whenever we add a certain solute, जब भी हम कुछ solute add करते हैं किसी solvent में, so what happens? There is a lowering of vapor pressure. So we are denoting that lowering in vapor pressure by P naught minus P. And this P naught minus P divided by the vapor pressure of the pure solvent. That is known as the relative lowering of vapor pressure. Now this lowering of vapor pressure, this relative lowering of vapor pressure, it is found that it is directly proportional to the mole fraction of the solute in the solution. More is the quantity of solute in the solution, more will be the relative lowering of vapor pressure. So we can say that this is a colligative property. We have already discussed that this is known as a Raoult's law of relative lowering of vapor pressure. So P naught minus P will be equal to how much? XB. And we have seen that XB is equal to how much? NB upon NA plus NB. So this is the formula for relative lowering of vapor pressure. And do remember that the lowering in vapor pressure is a colligative property. Now, if numerical can come on this, suppose we are given that A is a solvent, we will be given the mass of A. Suppose the solvent is a water. We know the molecular mass of water is how much? 18 gram. Suppose we are given 36 gram of water. So how much will be the number of moles of water? W upon ME. That will become how much? 36 upon 18. So that will come out to be 2. Now if they say that this is not dissolved in say glucose, we are dissolving glucose in water. Now the molecular mass of glucose is how much? So the molecular mass of glucose is how much? 80. So I'm denoting it by MB. What is the mass of Glucose, say we are given the mass of glucose is almost say 360 grams. So how much will be the number of moles of glucose? The number of moles of glucose will be the mass of glucose upon molecular mass of glucose. So molecular mass is over 360 divided by 180, that will come out to be say 2. Now in this particular case I have taken, this is the solute, I have taken it B. This is the solvent, this is B. So what will be the value of XB? XB will be given, XB will be how much? You know that is NB upon Na plus NB. So that will come out to be 2 upon 2 plus 2. So that will be 4. So that is how much? 1 and a half. So we have got the value of XB is how much? Half. So suppose we are given, say, the vapor pressure of pure water is, say, 50 atmosphere. And we have to find P. So we know P naught minus P divided by P naught will be equal to how much? XB. So P 50 minus P divided by 50 is equal to how much? Half. So we can now get the value of P. That will be twice into 50 minus P is equal to 50. So 100 minus 2P is equal to how much? 50. So 50 is equal to 2P. So the value of P will become how much? 25 atmosphere. So this was the first colligative property, which is the relative lowering of vapor pressure. The second colligative property is elevation in boiling point. So first of all, we should know what is boiling point. Boiling point is that temperature at which a liquid starts to boil. And when does a liquid boil? A liquid boils when the vapor pressure, when the vapor pressure becomes equal to the atmospheric pressure. And we know atmospheric pressure at a place is how much? 1 atmosphere. So when the vapor pressure will become equal to the atmospheric pressure, then the substance will start to boil. Now when, suppose I say pure solvent, I have taken a pure solvent. This is pure solvent. Say TB naught is the boiling point of pure solvent. Now if I add the solute to it, suppose I have added some solute to it. So whenever we add a solute to a solvent, what is observed? It is observed that its boiling point will increase. Boiling point of the solution. TB naught was the boiling point of the pure solvent. TB is the boiling point of the solution. Since when we are adding the solute, the boiling point is increased. So if I want to find the elevation in boiling point, I will have to subtract the boiling point of the solution by the boiling point of the pure solvent. And it is observed that this is directly proportional to M, where M stands for the molality. So I can say delta TB is how much? Directly proportional to M. So delta TB will be equal to how much? KB into M. So from here I can conclude that the elevation in boiling point is equal to the KB into M. This KB is known as the molar elevation constant. This is also known as the Ebuloscopy constant. So in case someone asks you what is molar elevation constant KB, that will be equal to delta TB upon M. And in case I have taken say molality is equal to 1, then KB will be equal to delta TB. So the molar elevation constant can be said to be equal to the elevation in boiling point, provided the molality is 1. Now, if I write the formula of molality, which I have already discussed in a previous video, delta TB is how much? KB into molality means the number of moles of solute divided by weight of solvent in gram. So that will become this. Now, this formula is very important from the numerical point of view. So I am denoting this equation by 1, this equation by I am denoting by 2. So this is the formula for elevation of boiling point. Delta T is denoting the on the numericals. Either we will have to calculate the elevation in boiling point, or also it can be given to find the molecular weight. In case you want to find the molecular weight, you can make it the subject, you can bring delta TB there. So the MB will become equal to how much? KB into WB into 1000 divided by delta TB into W. So this is the formula for elevation in boiling. The third colligative property is the depression in freezing point. It is observed that whenever we add a solute to a solvent, its freezing point decreases. And this depression in freezing point is again found to be directly proportional to the molality. So if TF naught is denoting the, it is denoting the freezing point of pure solvent. This is denoting the freezing point of the pure solvent. TF is the freezing point of solution. So what will be the depression in freezing point? Since the freezing point of pure solvent is more than the solution, there is a depression. So we will calculate TF naught minus T. And again, it is directly proportional to molality. So I can say that delta TF is directly proportional to M. If I remove the sign of proportionality, I have to write KF. So delta F is known as the KF, delta TF is equal to KF into M. This is known as the molar depression constant. This is also known as the cryoscopic constant. Again, M is a molality. And since the depression in freezing point is directly proportional to molality, so again it will be a colligative property because molality depends upon the quantity of solute. So I can say delta TF is equal to how much? KF into WB upon MB into 1000 divided by W. So this is the formula for depression in freezing point. But do remember that the freezing point decreases while the boiling point increases. The fourth property is colligative property is osmotic pressure. So for discussing osmotic pressure will be denoted by pi. The symbol phi osmotic pressure is pi, and it will be measured in atmosphere. So before going to studying atmospheric pressure, first of all, we should know what is osmosis. Osmosis is defined as the process, a phenomenon of the movement of solvent molecules. The process of the phenomenon of movement of the solvent particles from the region of their high concentration. From the region of their higher concentration. But I am talking about the solvent to keep in mind. The phenomenon of movement of the solvent molecules from the region of their higher concentration towards the region of their lower concentration. And it is very important that this is going to take place through a semi-permeable membrane. Semi-permeable membrane is a very essential condition for osmosis to occur. If there is no semi-permeable membrane, you will not call it a osmosis. So osmosis is the process of movement of the solvent particle from the region of their high concentration towards the region of their lower concentration through a semi-permeable membrane. Suppose I have taken, this is a container in which I am having a pure solvent here and I am having solution here. So now the concentration of the solvent will be more here because it is a pure solvent. Here it is a solution. So whatever solute is there, but there is a some solute. So the solvent molecules will now start to move from the region of the high concentration towards the region of low concentration. And what is this? This is a semi-permeable membrane. So as the solvent molecules will start to move from the region of the high concentration to lower concentration, what they will do? They will exert a certain pressure on this semi-permeable membrane. And this membrane, now if we want to stop the osmosis, we will have to apply a reverse pressure from, so this will be the measurement of the osmotic pressure. If that is, if we want to stop the process of osmosis, we will have to apply a certain pressure from outside. This will be known as the osmotic pressure. And it is observed that this osmotic pressure pi is directly proportional to concentration. It is also directly proportional to the temperature. Here C is denoting the concentration, T is the temperature. If I combine these two, I get pi is equal to C into T. On removing the proportionality of sign, I get C into R into C. So always remember here, it is very important point to note. Usually while doing the questions of in chemistry, we take the gas constant as how much? 8.31 joule per mole per Kelvin. But here we take the value of R as 0.0821 liter atmosphere per degree Kelvin. And pi will always be measured in atmosphere. The unit of pi is to be taken atmosphere. So if you are given the value of pi in any unit, you will have to convert it into atmosphere. And you might be knowing that one atmosphere is how much? 76 centimeter of mercury column or 700 millimeter of mercury column. That means if you are given pressure in centimeter, you have to convert it into atmosphere, you will divide the 76. And also the volume has to be taken in liter. Volume has to be in liter. Now here I am writing C. C is concentration. Now what is concentration? Concentration means number of moles of solute upon volume. So this formula can be rewritten as pi V is equal to NBRT. Now what is NB? NB is the number of moles. The number of moles can be written as mass upon molecular mass. So from here we can calculate the molecular mass. Molecular mass will be WB into RT upon pi into V. So this is the formula for molecular weight if we have to calculate it from osmotic pressure. So these are the four colligative properties. We can calculate the molecular mass from all of these four quantities. Now there is one term known as isotonic solution. Isotonic solutions are those solutions which have the same solutions having the same osmotic pressure are known as the isotonic solutions. Now just we have seen that pi is equal to how much? C into R into C. Pi is equal to this equation number 4. We have seen that pi is equal to C into R into C into R into T. Now if I have two solutions, say for the first solution, osmotic pressure is pi 1. Its concentration is C1 R into T. For the second solution, say I have pi 2 is equal to C2 into R into C. Now, since this reaction is the same, so temperature is also the same, R will be same. So I can say pi 1 upon pi 2 is equal to how much? C1 upon C2. Now, if pi 1 is equal to pi 2, since the solution is osmotic, isotonic, so what will happen? 1 will be equal to C1 upon C2. That will be that means C1 is equal to C2. So if I have two isotonic solutions, then do remember that their concentration will also be same.